Hi, today we look at Pharo. Pharo is a Smalltalk system, and Smalltalk is, as you probably know, a very old language, but it's also the father of a lot of modern techniques like test-driven development and the model view controller and probably other things I forgot about. Pharo is a system in itself. It has its own scheduling, it has its own memory management, and the strongest aspect of Pharo is, or rather Smalltalk, is probably its live programming capabilities. So we take a look at that by creating a very simple class. The class will have an instance variable that we will set from the outside. We also add an accessor for this instance variable so we can access it from the outside. And I think that will do to start with. So to start it going, we introduce a few system components. We open the transcript window. The transcript is a log window in the system. It can do more than that, but we use it as a log window. We also open the playground, and the playground is more or less a REPL, so we can interact with the system quickly and have it colorized and things like that. But first, some Smalltalk fundamentals. Smalltalk doesn't use methods or functions, it uses messages, and if you use Objective-C, you probably notice a lot of similarities because Objective-C was actually based on Smalltalk, but this is the original. So to start with, by sending a message to something, we essentially tells an object to do something, or we request it to do something. It doesn't respond, it will throw an error, and we have an option to rectify that if we want to. But by sending a message, we can do transcript, we can do show, and we can say it hello from playground. And we end the sentence with a dot, and the dot is very much similar to a semicolon in most other languages. It essentially tells the statement is ended here. We can now right click this line and we can press the do it button. And this will send this message to transcript, and transcript will output it. We can ask transcript to do a line break, and we press Ctrl D this time because it's faster. Now you won't see the line break, but if I run this line again and press Ctrl D, it will output on a new line. However, if I press Ctrl D again, it will not output on a new line, because unless we tell it to do a line break, it won't do a line break. We can also tell transcript to clear itself, so it's empty. We can erase this. This was just to demonstrate how the message passing works in Smalltalk. Next, we open the system browser, and the system browser is where all classes are defined in the system. This involves pretty much everything from the debugger to compiler to the windows to the font rendering, the scheduling, everything, the package management, the system. You can see serial ports, and you can do a lot of things from there. There's a web service and things in this as well. But we keep it simple now. We define a new package, and we define a package by right-clicking one of the existing packages to access this context menu. We select Add Package, and this will ask us to create a new package with a name that we decide now. We call it Demo Package. Press OK. And we'll focus the demo package. The demo package is currently empty, so we right click this empty window and we press the add class. This will open a template window. The template will say object first. This is the superclass of our new class. We're happy with it being object. And subclass is the argument that defines the name of our new class, and we call this demo class. We can also define instance variables if you want to, or package class variables if you want to. And of course, we can change what package it belongs to, but we want to create it in the demo package, so we leave it as B. We press OK. And now we introduced a new class. We don't have to recompile anything. It's immediately available. So we can instance this class. We can call it my class equals demo class new dot and press Ctrl D. You can see my class turned blue. This means it's now defined. So if we write new my class and press Ctrl I, we inspect it and we see it's a demo class, but that's it. We can also see that what it contains and what the heritage chain is. We're not interested in that, so we erase this. We want to define a constructor on this, a constructor message. And we do that by pressing the no messages. This opens a new template. We can erase this template. And we call it initialize with a demo argument. The demo argument will be an argument. And we want to initialize our superclass. So write self initialize. And then we assign our class instance variable, and we call the instance variable the argument equals an argument. As you can see, the argument is marked in red. This means it's not really existent. So when I save this, Smalltalk will offer me different resolutions. It also logs out this error to the transcript window. We're happy with being a new instance variable, so we press that. And as you can see now, it's blue. And it also automatically added the argument to our instance variables names. We want to access this variable. Actually, we do this first. Class, we inspect it, Ctrl I, and now you can see the argument is here. We didn't create a new instance, it just immediately propagated over the system, so it's very fast to work with, no recompile necessary. It's actually hot recompiles everything. But to create an accessor, we select the all protocol. Actually, we do it this way instead. We try to access the argument, and we press a dot and we press Ctrl P to print it, and it will output an error. It doesn't understand the argument. Why doesn't it understand the argument? Because we didn't define it. But we offer several options here. We can proceed and pretend like nothing happened. We can abandon, actually abort the call. We can debug, or we can create this message that it didn't understand. So we take create. We want to create it on the demo class. We don't want to classify it as at this time, so we press OK, and it automatically creates this method for us that says it responds to the argument, and this means the circumflex means it returns the argument. Yeah, we're fine with that. We proceed, and it says nil. Actually, Control P again, and it says nil. Why does it say nil? Because if we press Control I on just the class, you can see the argument is nil. We didn't actually set the argument. To set the argument, we need to do initialize with add demo argument, and we can say this. This is hello world. Control D, my class. Control P to Control I to inspect it, and we can see the argument is now set to hello world. So here we instance the class. We call the constructor, or actually we sent it a initialization message, and this is just for introspecting it. We could also write this like that, which probably looks very similar if you're familiar with Objective-C, like you usually type my class alloc init with argument hello world, like that in Objective-C. So you can see that the syntax is very similar, it's just without the additional brackets. We could actually write parentheses around it if we want to mimic this syntax very closely. However, we want to do this very easy. So we call this another class, and we call demo class with a demo argument hello again. And we press Ctrl D, and it says it doesn't understand with a demo argument. That's because we haven't defined it yet. So we take create. We want to define it on the demo class. We don't want to classify it, so we press OK. And we get this template. It responds to a demo argument. It takes a string. Actually, we take an argument. We don't want it to be a string. It could be anything. However, what we want is it to return self initialize with a demo argument, an argument. And we press Control. Actually, we want to do a new instance first. And we can press Control S. And we click proceed. And now another class can be introspected by Control I. And we see that it now, the argument, hello again. So to summarize this, we just log the contents of both those classes, my class, the argument, and another class, the argument, to the transcript, and press Control D, and it writes out hello world, like our first class has its instance variable set to, and writes out hello again, like the second instance has. And I believe this summarizes the basic introduction of Smalltalk and Pharo. Bye.